Describe fully a just single geometrical transformation U represented by the matrix A. There's two things that give this one away. First up, like the root 3 over 2 implies it's going to be some sort of rotation probably because that is an exact trig value. Sine 60, for example, with roots 3 over 2. And the other thing that gives it away is that these two are the same and these two are the same but opposite signs. Here's the formula for an anti-clockwise rotation. I'm not going to prove it here, but have a look into where it comes from. But we can quote it and then find out what theta is. So I'm going to go with sine theta equaling root 3 over 2. But if you do inverse sine of that, you'll get 60 degrees, or you'll also get 180 minus 60 degrees, 120 degrees. Then let's look at the cos one. Now you could do cos of 60 and cos of 120 and find out which one gives what is it, minus a half, but let's just instead do cos theta equals minus a half and solve that. Okay, so either way works fine. So I've done it here and we get 120 degrees. You'd also get 360 minus 120, 240, but we can see the common one is 120. So it's going to be an anti-clockwise rotation through 120 degrees about the origin. Next up, we're told that V represents a 2 by 2 matrix B. It's a reflection in the line y equals minus x. Write down the matrix B. We might have learned these by now, but if not, you can figure it out. Because if we apply it to xy, then x is going to become minus y, and y is going to become minus x. So we can just figure it out from there. So I need a 0 and a 0 here. And then if I want to get minus y, I need a minus 1 here. If I want to get minus x here, I need a minus 1 there. So that is actually going to be our answer, just this matrix here. Given that U followed by V is a transformation T, which is represented by C, find C. Okay, so it's U first, and that means it's going to be on the right, minus a half, minus root 3 over 2, root 3 over 2, because we sort of work from right to left, a bit like with functions, if you're doing it, composite functions. And then we're going to apply B, which is our 0, minus 1, minus 1, 0. And this ends up giving me, so I'm going to multiply along the row and the column, of course. So I get minus root 3 over 2, and then a half, then a half, and root 3 over 2. By the way, this is not going to be a rotation. It looks a bit like it, like I said up here, but this time these two are opposite signs. Of course, it's a rotation followed by a reflection. So finally, we're asked to show that there's a real number k for which 1k is invariant under T. So for a point to be invariant, then it would be that for some matrix A, for example, I've already used A. So for some matrix D, for example, if I apply it to a position vector, x, y, then I get the same position vector, i.e. the coordinate maps onto itself. Okay, that's how we can show it's invariant. So all we have to do is take our matrix that we just found, minus root 3 over 2, a half, and root 3 over 2, and apply it to this point, 1k. And then that is going to equal 1k. We're going to apply that and then work out what k is, because then that coordinate will be invariant. So I will get In fact, I can just write it as equations now. I don't need to keep it. I'll get minus root 3 over 2 plus a half k equals 1. And then a half plus root 3 over 2k equals k. So let's solve them and just show that they are consistent, that they both give the same solution. So first up, we're going to get, well, I'm going to multiply through by 2, I think. So minus root 3 plus k is equal to 2. Therefore, k will equal 2 plus root 3. All right, that wasn't too bad. Just got to check that it works here. Okay, this one's a little bit more complicated. So I could write it as a half equals k 1 minus root, actually, why don't I times by 2 again first? So 1 plus root 3k equals 2k. That means 1 is equal to 2k minus root 3k, and I can factorize the k out. So then k equals 1 over 2 minus root 3. And you can either put this in a calculator or rationalize the denominator, but you will again get 2 plus root 3. So therefore, 1, 2 plus root 3 is invariant under t. I mean, I'd shown it really. I found that value of k, but I think this is a nice way to conclude.